The purpose of this tutorial is to answer the questions for the conics review test. I'm going to do these fairly quickly. If you have any other questions, come to class and ask me. All right, the first three questions are to tell whether the parabola opens up, down, left, or right. The first one is in the form x equals something y squared, ay squared, and so it's going to open right or left. Because the a value is negative, this one will open to the left. The next one is in the form of y equals ax squared, because therefore it opens up or down because a is positive. This parabola will open up. This parabola opens, number 3 opens left or right, it's positive, so the parabola in number 3 opens to the right. We're going to match the equation with the graph. We have a lot more graphs than we have equations. Let's see what we can do. This, by the way, is a circle, and its center is 0, 0, and its radius is the square root of 8, which is approximately equal to 3, just a little bit less than 3. Where do I have circles that have a center at 0, 0? Well, just L and M. Which one of those has a radius that's a little bit less than 3? Clearly it is M, and so the answer to number 4 is M. Number 5 is a parabola. I could write this parabola as x is equal to negative 4y squared. I know it's a parabola, therefore, that opens up to the left, or opens to the left. It has a vertex at 0, 0. Where do I have parabolas that open left that have a vertex at 0, 0? There's one, and I believe there was another one, if I remember correctly. Yes, B and C are both 1. Lots of different ways we can do this. One of them is, let's look at this point out here at x equals negative 4. Here it looks like my y values would be 1 and negative 1. Here it looks like my y values would be about 4 and negative 4. Let's plug in negative 4 for x and see what happens. If I plug in a negative 4, I get y squared is equal to 1. Y is equal to plus or minus 1. Well, the ones that show plus or minus 1, B must be the correct answer. Number 6. Number 6 has an x squared and a y squared term, has a plus between the two, so I'm looking at an ellipse. I'm looking at an ellipse whose center is 1, negative 1. So let's find some ellipses whose center is 1, negative 1. Here's an ellipse whose center is 1, negative 1. Here's an ellipse whose center is 1, negative 1. That's all I see. Well, let's see. The x value, which is the left and right value, has a 4 underneath, meaning I'm going to go left and right 2 from the center. This one goes left and right 2 from the center. This one does not. It actually goes 3. Also, I should be going up and down 3. That's what this does. So the answer to number 6, therefore, is K. And number 7, I have two squared terms. I have a minus sign in between, so I know that this is an ellipse. I'm sorry, a hyperbola. This hyperbola whose center is 1, negative 1. Look for hyperbolas whose center is 1, negative 1. This is a hyperbola whose center is 1, negative 1. Do I have any other hyperbolas whose center is 1, negative 1? This is a hyperbola whose center is 1, negative 1. So D and I are my choices. Which way does it open? It opens up and down because the y value is first. The vertex has to be exactly 3 units away, the square root of 9 units away. So which one of these has a vertex that's exactly square root of 9 units away? The answer is D, and so 7 is D. Sketch the graph and indicate the points. Number 8 is a circle. Okay. With the circle, I have a center at negative 2, 1, because the negative 2 goes with the x, the 1 goes with the y. So I'll do negative 2, 1 as the center. The radius is the square root of 9, so the radius is equal to 3. I'm going to go 3 up, I'm going to go 3 right, I'm going to go 3 down, I'm going to go 3 left, and I'm going to try and make it look like a circle. Use your imagination. Pretend I drew a circle. There are the indicated points I want. The center, negative 2, 1, and the radius is 3. The second figure is a parabola. This parabola is going to open to the right, and the vertex is going to be at 0, -1. So there's my vertex at 0, -1. I'm opening to the right. I could pick a value for x, or in this case, what I'm really going to be looking for more than the 2 points, since this is my test, we can do the 2 points, but what I really want to know, where is the focus and where is the directrix? And I'm going to say C is equal to 1 over 4 times 1/2. So C is actually equal to 1/2. My focus here is going to be at 1/2, -1, and my directrix is going to be at x equals -1/2, C away. I guess we can go ahead and do the 2 points. Let me put in 1 for x. If I put in 1 for x, then 2 is equal to y plus 1 squared, and so y plus 1 is equal to the square root of 2, y is equal to -1 plus or minus the square root of 2. Maybe not my favorite point, but that'll work for what they asked. Finally, I've got an ellipse. Why? Because it has x squared and y squared term and a plus sign. The center is 0, 0. X value comes first. I'm going to go out the square root of 8 to root 2, which is, by the way, the center here is 0, 0. That's not going to be my vertices because these are going to be my co-vertices. It's the smaller number. That being said, I'm still going to go out just a little bit less than 3, 2 times the square root of 2. And then I'm going to go up and down 4. I go up 4, and I go down 4, and then I have my ellipse. Make sure you can also find the foci of that ellipse, but the vertices are going to be 0 plus or minus 4. All right, next is the hyperbola. How do I know? I have an x squared and y squared and a minus. This is going to open up because I see the y value first. And so my center is still at 0, 0, but I'm going to go up 2 to get a vertex. I'm going to go down 2 to get a vertex. My center is 0, 0. My vertices are at 0 plus or minus 2. Also, I'll end up wanting to make a box. I'm going to go left and right, the square root of 7, which is a little bit more than 2. To make this box, let's see, 1, a little bit more than 2. Then that will give me my asymptotes. Remember, this is going up and down, and so I'm going to get close as I can to the asymptotes here, close as I can to the asymptotes here. That's what my hyperbola actually looks like. This next graph, number 12, is also an ellipse because I have an x squared and a y squared and a plus sign. My center is going to be at 3, 2. So there's a center at 3, 2. My vertices are going to be underneath the y because the y value has the biggest number. I'm going to go up 3 and down 3 to get to my vertices. So it's going to be 3, 2 plus 3, which is 5, and 3, 2 minus 3, which is -1. I'm also going to go left 1, right 1, and left 1, and then I will have an ellipse that looks something like that if I can draw. This last one for number 13 is actually a hyperbola. Why? Because there's a minus sign there between the two squares. The center of my hyperbola is -1, 3. This one starts with an x, so it's going to go left and right. So my vertices are going to be the square root of 4 to the left, square root of 4 to the right. I know I always say to the left and draw to the right. I'm going to go ahead and do my box, which goes up 3 and down 3. 1, 2, 3. Now that I have my box, I can draw my asymptotes. I'm going to go left and right from here, left and right from here. There's my hyperbola. The center of the hyperbola, once again, was -1, 3, and the vertices going left and right 2 from there are going to be at 1, 3, and at -3, 3. What are the co-vertices in question 10? Well, let me back up to question 10. Here is 10. The co-vertices are going to be the square root of 8 away. So my co-vertices are going to be 2 root 2, 0, and negative 2 root 2, 0. Transferring that over to the next sheet. Let's do it. Plus or minus 2 root 2, which is the square root of 8, 0. What are the covertices in question 12? Remember, my center's at 3, 2. My covertices are going one to the left and right. And so I will have one at 2, 2, and another covertex at 4, 2. All right, a circle centered at negative 4, 5, diameter of 4 root 3. The circle then would be x plus 4 squared plus y minus 5 squared is equal to, well, if the diameter is 4 root 3, the radius is 2 root 3. 2 root 3 squared is 2 times 2 times 3, which is 12. An ellipse centered at 3, negative 6, passing through 6, negative 6, and 10, 0. I told you for the test I wouldn't give you one out here at this point, and so let me change that to 3, 0. Well, let's make it 3, 8. Just give us something exciting to do. Let's try it this way. Now what would I have? Remember, I'm going to be at 3, negative 6, and if I'm going through 6, negative 6, I've gone 3 out in the x direction. And if I look at the point 3, 8, I'm going 14 in the y direction. That's how far I am going away on this ellipse. And so I can write, I know it's going to be x minus 3 squared over something squared, because it's an ellipse, it's plus, y plus 6 squared over something squared is equal to 1. Well, if I went left and right 3, that's going to be 3 squared is 9. If I go up and down 14, that's going to be 14 squared, 196. And that would be my solution. Okay, I've got an ellipse now. The ellipse is centered at 2, 0, and it has a horizontal axis 12 units long, so 12 out this way, and a vertical axis 3 times the square root of 5 units. Well, my equation is going to be x minus 2 squared plus y squared, both of those over something, is equal to 1. If the x units went 12, 12 squared is 144. If the y distance is 3 root 5, 3 root 5 squared is 3 times 5, which is 45. All right, write the standard form of the conic. Well, what is the first conic? It's a circle. Its center is going to be 1, 2, 3, 1, 2. So I have a center at 3, 2. And I have a radius of 1, 2 units. So I can write this as x minus 3 squared plus y minus 2 squared is equal to 2 squared, which is equal to 4. This next one is an ellipse. Here's the center. The center is at 2, negative 2. I'm going up 2 in the y direction. I'm going over 1, 2, 3, 4, 5 in the x direction. I'm going to write this as x minus 2 squared over 5 squared plus y plus 2 squared over, what we said, it was 2, 4, 2 squared is equal to 1. And the next conic is a hyperbola, so I know my center is 0, 0, so it's going to be x squared over something squared minus y squared over something squared is equal to 1 because my center was 0, 0. Now, actually, I got to take that back. Why do I have to take it back? Because I'm opening up and down. That means my y squared value has to go first. I'm going to put y squared minus x squared. Okay. The y squared one's going to be real easy. How far up am I going? 1, 2, 3. So the y squared is going to be over 3 squared, which is 9. Now, how far do I have to go out to make my box? Well, remember, we're running through the box, and so I went left and right 2. If I'm going left and right 2, 2 squared is 4, and I get y squared minus over 9 minus x squared over 4 equals 1. All right, 22 through 25, let's classify the conic. It has an x squared and a y squared term, 22 does, so it's not a parabola. They both the x squared and y squared terms have the same sign, so it's not a hyperbola. However, these numbers are different, so this is an ellipse. The second one has an x squared and y squared term, so it's not a parabola. The x squared term is positive, the y squared term is negative, so it's a hyperbola. That's an E, by the way. E. Number 24 has a y squared term but has no x squared term. Even there are two x's here, they're both x's and not x squared terms. This one has to be a parabola. And finally, this one has an x squared and y squared term. It's not a parabola. The x squared term has a 2. The y squared term has a negative 2. Since they're opposite signs, this has to be a hyperbola. Write the equation in standard form. I'm going to combine these. I'm going to say x squared plus 10x plus y squared minus 2y is equal to 10. In order to complete the square here, I'm going to take half of 10 is 5. 5 squared is 25. I'm going to have to add 25 to this side also. Half of negative 2 is negative 1. Negative 1 squared is plus 1, so I'll put a plus 1. This is a perfect square. It's x plus 5 squared. This is a perfect square. It's y minus 1 squared is equal to 36. So there you go. That is the equation standard form. That's a circle. X minus 8 squared plus y minus k squared is r squared. So I would just take this and move it here. All right, for the next one, I've got 4x squared minus 8x plus 2y squared plus 12y is equal to 3. And I'm going to factor out a 4. I'll get 4 times x squared minus 2x plus 2 times y squared plus 6y is equal to 3. Half of negative 2 is negative 1. Negative 1 squared is 1, so I added a 1. But I didn't really add a 1. I really added a 4 times 1, which is a 4. Half of 6 is 3. 3 squared is 9. But I didn't really add a 9. I really added 2 times 9, which is 18. So I can write this as 4 times x minus 1 squared plus 2 times y plus 3 squared is equal to 25. That's kind of yucky looking numbers, but I guess we'll just have to deal with it like it is. So because this has to be an ellipse, I'm going to have to make it be a 1 on this side. I'll divide everything through by 25, and I'll get 4 times x minus 1 squared over 25, or 4/5 x minus 1 squared, plus 2 times y plus 3 squared over 25, or 2/25 y plus 3 squared is equal to 1. And I believe that will do it. Any questions, please come see me. I want you to do well on this test. Thanks.